Welcome to this talk about seamless database management for Cloud Foundry and Kubernetes. My name is Julian Fischer. I'm CEO of a company called Anynines, which is focused on the development of database automation and building and operating contemporary application developer platforms. In this talk, looking at database automation across multiple platforms such as Cloud Foundry and Kubernetes, we will explore a technology called Klutch, which is open source under the Apache 2 license and addresses exactly that cross-platform database and data service management issue. Klutch is open source. It simplifies data service automation, works across infrastructures, supports both Cloud Foundry and Kubernetes, addresses the Cloud Foundry data service challenge, provides centralized control, enables high operational efficiency as similar to what you're used to using Cloud Foundry, and streamlines database management across multiple automation backends while enabling on-demand service and leveraging the power of Crossplane when writing database automation backend integrations. All right, so we are answering a few of the questions. First and foremost, what is Klutch and where is Klutch useful? What are the basics on how Klutch work? And what does Klutch do for Cloud Foundry? We will also look into where it is now and where it is headed. So first of all, if you are already a Cloud Foundry user, which I assume, then you know that you got your Cloud Foundry environments, and potentially in order to integrate databases and database management automation, you are very much likely to use open service broker API compliant service brokers, which will then interface with your data service automation. At Anynines, we offer a Cloud Foundry stack as well as a set of data services called the Anynines data services, where we do on-demand provisioning of dedicated virtual machines using Bosch automation. So we have our own service brokers. We also do develop Kubernetes operators. So we have a set of service brokers that integrate well with Cloud Foundry. Now, if you're using Cloud Foundry and that's all you use, this is fine. It works. We've been doing this for 10 years. We are running Cloud Foundry environments across all major infrastructures on behalf of our clients, running 10,000s of virtual machines for both Cloud Foundry applications as well as for data service instances. Now, but the elephant in the room these days is obviously that any organization has a high incentive to also adapt Kubernetes, and the question is how to do that meaningfully. Because in the past years, we've seen that the cloud service challenge, the data service challenge that also exists in Cloud Foundry, assuming that you have a Cloud Foundry and now you need the most popular databases out there, well integrated in your Cloud Foundry, also exists in Kubernetes. But without a strong multi-tenancy concept in Kubernetes itself, the cloud service challenge is actually more complicated than in Cloud Foundry. So how to solve this data service challenge is something that is interesting to talk about, and which is Klutch primarily addressing. For small-scale Kubernetes platforms, you have your applications in your Kubernetes cluster, and you may get away with having operators running in the same Kubernetes cluster operated by your cross-functional team, and assuming that this is a highly skilled, highly trained team that also knows how to operate databases, you might get away with this. However, for large-scale Kubernetes platforms, organizations that are more likely to have dozens or hundreds of Kubernetes clusters, that pattern doesn't really scale well because of operational efficiencies, but also you need to scale the skills necessary to do data service automation in each Kubernetes cluster. So even with automation, it's not impossible, but it's getting harder. So the general consensus is that separating the application load from the data service load is a best practice. So this pattern doesn't scale well. And therefore, you need a solution or a technology that allows you to separate the application workload from data services while enabling that local on-demand developer self-service that you would also have with the Cloud Foundry. So this is what Klutch actually does. It provides you with an extension, the Klutch client, that you can plug into any application cluster, any Kubernetes cluster there is, and it will basically introduce local CRDs, allowing you to control the creation and maintenance of service instances, service bindings, backup and restores, similar to what you know from Cloud Foundry's marketplace, but in Kubernetes. And it does that across a large number of Kubernetes clusters while introducing a central control plane that allows the integration of arbitrary automation backends using Crossplane as an integration layer. So the Klutch control plane basically introduces that central control plane where the Klutch connector or Klutch client introduces that lightweight operator that you plug into your local clusters that allows you, your application developers, to declare a service instance, let's say for a Postgres database locally, which will then be replicated to the Klutch control plane, which will then reconcile with the automation backend. All these Klutch components are natively written in Go, so they are a Kubernetes workload. The main achievement here is that the service instances are separated from the application cluster, which means that the automation backend can be operated by platform teams that are specialized in doing that. If you create thousands of data service instances, that's a best practice and helps to get the pain of running databases away from your application developer teams. It's also important to mention that Klutch allows for the integration of arbitrary automation backends. You're not bound to a particular automation backend. If on AWS, for example, you want to have DynamoDB instances exposed to your application developers, you're free to do so. If you're using, let's say, the anynines databases like we do, you're free to do so. If you want to go with open source operators, you're free to integrate them as well. So Klutch is open source and it's agnostic to the automation backend you're using. You're free to implement your own automation backends. Writing automation backends leverages the power of Crossplane, as Crossplane is the way to go when you want to reconcile resources that are not necessarily in Kubernetes, using Kubernetes control loop and declarative approach to reconcile those external resources. So in Klutch, you're basically writing integrations for automation backends using Crossplane, telling Klutch how to create a service instance, how to create a service binding, how to create a backup and a restore. In other words, the Klutch control plane introduces sort of a cloud controller in a fleet of Kubernetes clusters. So where Cloud Foundry has Cloud Foundry organizations separating tenants from another, in Kubernetes often you need to create dedicated Kubernetes clusters. And for each Kubernetes cluster, where and how do you integrate data services is an issue. So Klutch does that by using that Klutch control plane centrally and plugging in the Klutch client into every Kubernetes cluster where there are applications. So the application clusters are basically equipped with the Klutch client, where the centralized control plane introduces that central governance and central monitoring capabilities that also come with the Cloud Foundry controller, the cloud controller. Klutch also works across different infrastructures. It's a Kubernetes workload, and as you can integrate arbitrary automation backends, the data services that you can expose to your Kubernetes application cluster strongly depends on the portability of your automation backends. The anynines data services, for example, that use BOSH as the infrastructure abstraction, run on any on-premise and private cloud. The AWS data services, which represent the Kubernetes operators and create pods. They also run on any infrastructure. And in addition to that, we are working on integration backends for AWS, Azure, Google Cloud, and Ali Cloud, for example. So you can expose those services to the application developers as well. I mean, obviously, those integrations will have some differences in configuration of service instances. But for example, Postgres instances will provide you with, from the application perspective, a somewhat homogeneous experience, where other databases like DynamoDB and document databases provided by other infrastructure providers obviously have more heterogeneity. All right, so the application developer perspective from a Kubernetes cluster perspective or Kubernetes application developer perspective is also interesting. First, as this is a Cloud Foundry conference, the heritage of Cloud Foundry is absolutely clear and very important to us. So Klutch does not abandon the open service broker API abstractions. It actually elevates them. It keeps the nouns, but evolves verbs to reflect how modern teams operate by being declarative and developed and event-driven. In particular, we use the same abstractions. We use the service plan to create a service instance by providing a well-tested configuration set or set of configuration parameters. We do provide the service binding abstraction to bind applications to service instances. And as you know from the anynines data services, if you have ever worked with them, we also have an API for backups and restore and creating backups regularly using service plans. And these abstractions are built into Klutch natively. So the service plan and service instance declaration, for example, using a Postgres here, as you can see below, it's AWS Postgres, which means in this case, the service instance is being represented as a pod. The service plan is single nano, which means it's a very tiny service instance, and it only has one pod and no asynchronous streaming replication. If you were to change to a different automation backend here, you would still create a Postgres instance here, also the same plan, single nano, which means you create one VM in this case, also a very small one, but you're using anynines Postgres as the backend, which creates VM and not a pod. So this example shows how an application developer can basically adapt a local a YAML file that would be applied to a local application developer cluster to create a service instance that could be represented by a VM or by a pod someplace else. So in both cases, the service instance would not be in the application cluster, but somewhere else. And Klutch takes care of the reconciliation of that service instance being created. But not only that, you have the declared state of that service instance obviously in the application cluster, but it will also be automatically replicated to the Klutch control plane, providing you that cloud controller like central metadata registry. This example shows how a MongoDB instance is created, here using the anynines MongoDB as a backend. As you can see, pretty similar to what you do in Cloud Foundry. The same is for service bindings. You have service bindings, in this case, AWS Postgres. And in this case, Klutch creates a local secret in the application cluster so that you can reference the secret that is created along with the service binding from your application and just read the credentials, similar to what the vcap services environment variable would do in Cloud Foundry. So here's a brief demonstration on how to use Klutch on Kubernetes from the perspective of an application developer in an application cluster. So this is the spec of a Postgres service instance. Again, this is a single instance without stream replication, a small instance in this case. You apply the service instance spec to the local application cluster. The local application cluster then replicates this declaration to the Klutch control plane, and in the background the Klutch control plane reconciles with the automation backend and creates the service instance. Once this is done, you can create your service binding, which declares the intent that you would like to have a database user and a local secret to read the access credential to get to the Postgres instance from your application. So along with the service binding, there's also a secret being created, which is what your application can read. So in this case, read your username and password from the secret, and here it is. So pretty straightforward. This is similar to what you would get in Cloud Foundry. Now, what Klutch does is, as I said before, it allows you to solve the cloud service challenge in Kubernetes when your organization faces to the challenge on how to expose data services in a meaningfully standardized way to a lot of application developers using a lot of Kubernetes clusters. Now, once you have adopted Klutch, why have your automation backends being exposed in Kubernetes in one way and in Cloud Foundry in another way? So the question is, shouldn't Klutch become the central control plane for cloud service automation beyond Cloud Foundry and beyond Kubernetes? So in this case, you just take Cloud Foundry, you implement a service broker that translates to Klutch, which should be relatively easy to accomplish because Klutch introduces and uses the same abstractions as the Open Service Broker API does, in the sense that it also has support for service instances that derive from a service plan. It provides service bindings as well. So why not just have the integration of Klutch in Cloud Foundry? And this is exactly what the Klutch Service Broker offers. Here, the implementation example shows the CF Marketplace command, where after you execute CF Marketplace, the Klutch Service Broker lists the backend. In this case, it's anynines Postgres. It's the service broker that we have. And anynines Postgres comes with a service broker, but this service broker is not integrated in Cloud Foundry directly, but through Klutch. So it's the Klutch service broker that funnels every request through the Klutch control plane back to the Cloud Foundry, to the anynines Postgres service broker. And the benefit you get from that is that the Klutch control plane knows about all the service instances, whether they are in Kubernetes or whether they are in Cloud Foundry. Similar to using the anynines data service or the anynines Postgres service broker directly in Cloud Foundry, you can obviously also create a service instance. So CF create service, straightforward. Using anynines Postgres as an example, where you could use any other backend that exposed to Klutch as well. So this is pretty much what you would do. You can pass custom parameters, select your service plan, and there you go. I have to mention that this service broker is currently in beta, so it's still in the making and it will become a bit more convenient in later versions. So once you've created your service instance, you would expect that there's a Postgres instance being created in the Klutch control plane, and there it is. been reconciled, service instance is available. So now you have to wait for the service instance to become ready. So you watch for the Postgres instance to be ready, and there you go. Once the service instance is ready, you can create a service binding, or in this case, because we don't have an app deployed, create a service key, which is basically doing the same thing. So again, we're using create service key or service binding, reference the service instance you've created, and wait for the service binding to be there and to be reconciled. You can also see in the Klutch control plane that the service binding object is created in Kubernetes and that it is successfully reconciled. There you go. You can also see that the local secret is created. So the secrets are also available in the Klutch control plane. And that using this secret, you can then read the credentials and there you go. Well, obviously, you can use those credentials to access the Postgres. You can use PSQL, use the credentials extracted from the secret, and there you go. You're on your Postgres instance. So, as a summary, Klutch is a new open source based technology that not only solves the cloud service challenge when using a lot of Kubernetes clusters, but it also allows you to have one control plane that is shared among Kubernetes clusters as well as Cloud Foundry environments to systematically expose data service automation backends in your application developer platforms while enabling you with the central control. So Klutch is the foundation, in our opinion, to also provide, for example, Kubernetes-based operators in Cloud Foundry environments to solve the problem on how to bring automation backend systematically to Kubernetes developers, and thus also forms a foundation for long-term platform strategies, including the use of Core-FE in Kubernetes. So Klutch enables data service management across Cloud Foundry and Kubernetes platforms, across infrastructures, providing on-demand self-service, integrating a wide range of data service backends. The status of Klutch is also that Klutch itself, the framework is built, it's implemented in its first version, it's fully functional, can be downloaded and used right away. The multi-tenancy capability and more about authentication and authorization is something that is about to be developed. We also do have additional components, some of which are commercial, where, for example, you have service connectors connecting application clusters with the automation backend networks dynamically as service bindings are being created, as well as securing these connections dynamically as you declare service bindings. The Klutch service broker that you have seen in the demo earlier is early stage. This is the first implementation. So right now the anynines data servers are integrated, but support for AWS Postgres and AWS is upcoming. So as we integrate more automation backends, we also increase adapt the open service broker respectively. The service broker eventually will become so generic so that whenever you integrate an automation backend in Klutch, the service broker is capable of automatically exposing it to Cloud Foundry users with minimum configuration and most preferably without any further need to implement a service broker other than configuring it maybe. The Klutch network connector and service card will also be enhanced as it is currently in an early stage version. Backend integrations are available for the anynines data services, the ADAS Postgres at the moment. Also, AWS S3 is there. Upcoming is RDS and DynamoDB. But as this is open source, so you are free to implement your own automation, your backends, and get in touch with Klutch. Give it a star on anynines. You can download Klutch and try it out on your own laptop using Kind and Minikube. Give it a star if you like it. And if you want to see it run on your own infrastructure, just reach out to us. We are currently accepting POCs to verify that it works across a wide range of different environments. So as I said, you can try your own self-demo. Just go to the Klutch.io website, download it, try it out yourself. Yeah. Any questions? Just reach out. We are happy, to answer any questions you might possibly have. Thank you very much for your time, and see you soon.